So in this video, we're going to graph some circles. We're going to study the circle equation and graph some circles. So first, if we're going to graph some circles, let's try to generate the equation of a circle. So on my notepaper here, I've drawn a circle for you. Still have our XY axes. Let's look at a point. So I'm labeling a point on the circle, and I'm going to label that point x comma y. So let's try to relate x and y in this circle. And to do this, I'm going to draw a right triangle. So I'm going to draw a right triangle using that point on the circle. Well, if you think about it, that leg on the x-axis has a length of x. The leg going up has a length of y. So we've identified the two lengths of sides of our right triangle. And if you notice, the hypotenuse of that triangle is the radius of the circle. So my two sides are x and y, and the hypotenuse is the radius. Let's look at another point in red here. I'm also going to label this point x comma y. And again, the leg on the x-axis has a length of x. The leg going up has a length of y. And the hypotenuse is the radius of the circle. So this is going to happen every time for all your points on the circle. Just to show it one more time, I'm going to do one more in green here. That point on the circle is x comma y. The leg of the right triangle on the x-axis has a length of x. The other leg is y. And the hypotenuse is r. So it looks like we can relate x and y in this circle using a Pythagorean theorem. The standard form of the circle is definitely going to have a Pythagorean theorem look to it. So for each point on the circle, it's going to be x squared plus y squared equals r squared. So that's going to be true for every single point on the circle. So that is the standard form of the circle equation. Let's look at an example. So for this example, I have x squared plus y squared equals 9, and I want to graph this circle. For now, all the problems we're going to do have a x squared plus y squared. That's how they're going to look. So that implies the center is at 0, 0. A little bit later in this chapter, we'll have different centers. But for now, we're going to be dealing with problems that look like x squared plus y squared, and the center is going to be at 0, 0. For this problem, r squared is 9, so r equals 3. Again, it's important to remember that number out there is r squared. A lot of students see the number and they say the radius is 9, but no, 9 is r squared, so r is 3. So here's my circle with a radius of 3, and that's my graph. It's that simple. So it makes sense that the point 3 comma 0 is on my circle. If you plug in 3 for x and 0 for y, you get a true statement. 3 squared plus 0 equals 9. Same thing with this point, 0, negative 3. That point should be on the circle. If you plug in 0 for x and negative 3 for y, you get another true statement. Negative 3 squared is equal to 9. So there's my circle. All right, another example problem. This time we're not in standard form yet. If you notice, it's kind of all mixed up here. Standard form has x squared plus y squared on the same side and r squared off to its own side. So we got to move some stuff around here. We got to move the y squared over to the left, and we got to move that -4 over to the right. So x squared plus y squared equals 4 is now in standard form. Again, our center for now is going to be 0, 0. R squared is 4, so my radius is 2. So that should be a quick, easy sketch. Just draw up some axes. If it's going to be a true circle, you know, these dash marks on your axes have to be pretty equal. So you got to get good at that. If my circle is going to, you know, be a circle, those dash marks got to be equal. So here is my circle with a radius of 2. My graph is done. So let's look at another problem you might see. Write the equation of the circle that has center 0, 0 and passes through the point 1, 4. Well, for now, my center is 0, 0, so pretty much I'm always going to have this x squared plus y squared in my equation. All that's really missing is my r squared. So to know what goes there, I'm basically going to need to know what my radius is. And really, you could do this without a sketch. I'm just going to make a quick sketch here to kind of show you what we're trying to get at. You really could do these problems without a sketch, but for this first time, it's going to kind of help to see it. So I'm sketching a rough sketch here of my circle. All I know is that the point 1, 4 is on the circle. So that's what I'm showing here. So to get my radius, I'm going to want to draw the right triangle. And to see it a little better, I'm drawing it out on the side here. So I want to know what the radius is, so I want to know what the hypotenuse of this circle is. Well, if the point 1, 4 is on the circle and kind of made this triangle, the lower leg is 1, the other leg is 4, and my hypotenuse is r. So doing a quick Pythagorean theorem, 1 squared plus 4 squared equals r squared. So r squared is 17, r is root 17. Now be careful here. A lot of students, you know, make this calculation and they think what goes in the blank is root 17. But in the standard form of the circle, what goes there is r squared. R squared is what goes at the end there. So what's really going to go at the end for our equation is 17. Yes, the radius is root 17, but what goes in the equation is r squared. So there is my final answer. Okay, here is another type of equation. Write the equation of the line that is tangent to the circle at the given point. Recall that tangent means the line is only touching the circle at one point. Tangent only touches at one point. So my circle is x squared plus y squared equals 10, and my point of tangency is 1, 3. So to visualize this, I'm going to make a sketch of the circle. R squared is 10, so my R value is a decimal. It's roughly just above 3, right? Because if it was 9, the radius would be 3. So if it's 10, it's just above 3. So here's my circle. I'm going to highlight the point 1, comma 3. And I'm going to draw this tangent line as this dotted line. It's only touching the circle at 1, comma 3. So I want to know what is the equation of this dotted line. Okay, so to do this, we're going to want to observe the radius that goes to the point. Because if it's tangent, the tangent line is going to be perpendicular to that radius. So I need to know the slope of this radius that I've drawn in a solid black line here. Well, the radius goes from 0.00 to 1, comma 3, so we should be able to get that slope. 3 minus 0 over 1 minus 0, that slope is 3. So the slope of the dotted line can be found now. The tangent line, again, is tangent to the circle, so it's perpendicular to the radius. That is a key characteristic of the tangent line. It's perpendicular to the radius. The radius had a slope of 3, so the dotted line has a slope of negative 1/3, according to perpendicular lines. So I'm ready to write my equation. I'm going to write it in slope-intercept form. I'm going to plug in a point that I know, 1, comma 3, and I'm going to plug in the slope that I know, negative 1/3, and I'm going to solve for b. So I'm not showing the work here, but if you work it out, b is equal to 10 over 3. So I'm ready to write my final equation here. The equation of that dotted tangent line is going to be y equals negative 1/3 x plus 10/3. There is my final answer. That's the equation of that dotted tangent line. Alright, so one more problem I want to talk about, just to give you a heads up on what to expect. I won't go all the way through it, but I just want to give you a little heads up. What if they were to ask you to graph 5x squared plus 5y squared equals 40? Well, it's not in standard form, because standard form has x squared plus y squared with no numbers in front. No numbers in front. So we want to divide everything by 5. That's going to leave us with x squared plus y squared equals 8. So now we're in standard form. Now we identify that r squared equals 8, and r is 2 root 2. So now go from there. So if you ever see a problem like that, gotta get no numbers in front of x squared and y squared.